Hi, I'm Narayan Desai from Google. I spend a lot of my time working on data analytics systems, and they have a particularly difficult problem in front of them with regards to SLOs. So this talk really came from a deep-seated fear about the lack of precision in our SLOs and their ability to really drive us off track. This is sort of ironic. One of the fun things about giving talks at conferences is you never know what people are going to talk about sort of around your talk or before your talk. There have been a bunch of talks around SLOs. There have been relevant points hit in both of the keynotes yesterday. And the previous speaker was talking about how you don't need precision in lots of cases, and approximations is good enough for what I used to call government work. The thing that's really sort of ironic here is I think the answer is it really depends. It depends on what you want to do. And so in the case of SLOs, if you only remember one thing from this talk, the most important thing to think about is the idea that we need to understand how precise our tools are and what they're actually good for. And if we're using them in situations where we assume that they are more precise than they are, they're going to send us in the wrong direction. OK, so this is what we want SLOs to be. We would all love a treasure map. And we just take out our treasure map, and it tells us which direction to go. We know that we need to work a little bit on latency this week, and we have plenty of error budget left for features next week, and the week after that we need to work on a third thing. We have a really clear and unambiguous plan. And we know it's all data-driven, and we know which way we should go, right? The problem here is that this is only a model, right? Like wherever you're trying to get, it's not on that sheet of paper. And there's going to be nuances that are not captured in the map. Right? And sometimes maybe this map captures all of the relevant details, but there are other maps like this one that really don't capture all the relevant details. Like we can all kind of tell it's the Earth. We can tell that there's a bunch of continents. If you look at that, you're like, well, this is maybe sort of OK, until you realize it's missing a continent, and none of the shapes of the continents are actually right. So this is really an approximation, and it's a very, very coarse model. The problem is we can't actually tackle the full richness of the world in every sort of analysis that we perform. And so we need to do simplification in order to make things make sense. But the problem is when you do simplifications, sometimes you'll simplify in a way that's completely reasonable. And in other cases, you'll oversimplify. And when you oversimplify, that's when bad things happen, right? And so we need to be really specific about what our models are good for and what they aren't good for and when they break down and how they break down. And that's really the focus of this talk. So SLOs, we talk about SLOs in terms of a really low-level technical description, right? Their metrics and goals and so forth. But I think this doesn't really help us because if you think about when you're solving a problem, it's really all about the problems that we're trying to solve with the SLOs as opposed to the SLOs themselves, right? So if you think about what we're trying to do, how many people adopted SLOs because that's the first thing that SREs are supposed to do, right? Probably at least a few people, right? I see some hands going up, right? This is how tribal wisdom sort of gathers, right? But this is a little bit a joke and a little bit not, right? Like this is the first thing that we do, but we need to get much more specific. Really what we want out of SLOs is focus, right? We want to know what we're supposed to be doing and why, and have sort of a principled decision-making process behind it. We want to be able to communicate and coordinate with other teams around us, right? One of the things that I think is the most important about SLOs is that they allow you to build really rich ecosystems of microservices, right? Hundreds or thousands or tens of thousands of services that can be freely consumed without each consuming team having to negotiate individually with the providing teams. It's about disintermediation to make this process happen smoothly. And the thing is, inherently in all of these SLOs is a model of delivered service. And that model could be good or that model could be bad, but we need to be really specific what we're talking about when we try to make this decision. You made a bunch of great points yesterday about SLOs and how really what we all want is business success. I think that we would all like nothing more than to be able to write SLOs around business success. Like I think that everyone would like to be able to write the profit margin and run rate SLOs for their business, where just month over month they're hitting their numbers. But we're so far from that it's not even funny, right? And so we need to start approaching this in a much more incremental way to start with. And we keep adding more and more things onto this sort of concept in terms of the kinds of decision making we'd like to enable and so forth. So this is the pedestrian view of SLOs, right? SLOs are just measuring a thing and setting a goal around it. And that thing is probably some sort of API, and you're going to measure a bunch of events, and you're going to think about things like latency and availability and so forth. And there's a bunch of inherent things about the methods that we use that imply that our model of our service includes a couple of things. One is independent requests, right? So the assumption is you make one request, and it succeeds or fails, and then you make another request, and that one will independently succeed or fail. Like, this is sort of the basics of a lot of statistical methods. We also assume that all of these requests are of uniform importance, right? If you're thinking about a DNS server, it's probably not the case that particular requests are much more valuable than others, but if you're in an enterprise software context, there probably are some operations that are far more valuable than others. And the third thing is, we sort of assume that errors are relatively uniformly distributed. So we generally characterize these things in terms of a ratio or percentile, right? But this is just the sort of raw mechanism that we use to characterize an SLO. It doesn't really talk about what we're trying to achieve. When you think about use cases, I think this does a pretty good job of breaking it up. There's 4 sort of rough stages or rough activities that we have that we think about SLOs, right? So on an ongoing basis, these are the sort of the bread and butter of SLOs, right? This is providers thinking about what it is they're trying to provide and then managing towards those, right? So you set your SLOs, you measure your SLOs, you see if you're conforming to them, and if you're not conforming to them, you start to slow down, or you start to invest in reliability some more, or you optimize something if you're not hitting your latency numbers or whatever. The second part is really around how you interact with a service in terms of design. So from the service provider side of things, the provider really wants to set expectations for customers, to tell customers what they can expect. So we have this phrase at Google that if you don't set an SLO, your customers will happily make one up for you, right? And it's generally based on what they've seen, and that may or may not be accurate, right? Because they may not have a particularly comprehensive picture. And so it's really important for a provider to be able to say, this is what you should expect for this service. But from the customer perspective, there's a bunch of things that the customer wants to be able to do. So when you look at adopting a new service, you want to answer a bunch of questions about how mature that service is. Is this storage system going to eat my data? Is this thing going to be available? Is there, like one of the proxies that we use at Google is there a fully staffed on-call rotation for this service or not? There are all of these things that you use as sort of a sniff test for, is this dependency a safe dependency for me to take in my service? And part of that is, what is the performance that I can expect from this particular component? Another aspect is, when I use this service, am I going to be able to use it effectively? Right? Am I following best practices? Is my use case for this component going to match what the component has been built to deliver? And is that going to all work out? And really, at the end of the day, you want to know what the service is going to do under load, right? So, every day you're going to be serving queries, and are those queries going to be fast or slow? Are you going to have availability problems with retransmits or retries or whatever? The third major category here is response, like incident response. So something is going on, and there's really 2 different things that, and this is where you see slightly different priorities. So from the perspective of the service provider, what you really want to be able to do in the case of an incident is figure out how big of a problem that you have, right? And in the case of big incidents, you know how big of a problem that you have. But it's the ones that are marginal where maybe you need to decide whether or not this issue is a P2 bug or an active incident. Should you be paging a person or just sending an email alert? It's all of these things that are on the sort of fuzzy boundary of like big deal or not a big deal. And then on the consumer side, when you're using a service, you want to make sure that when you have a problem, your service that is providing infrastructure to you also thinks they have a problem, so they're going to work on fixing the problem in a timely fashion, right? And these are both very similar overlapping things, but from very different perspectives, right? So from the perspective of a consumer, you want to make sure that problems get fixed quickly. from the point of view of the provider, they really want to make sure that they can prioritize effectively because they always have more issues to solve than they have time to solve them. And then the last part is, I think, the scariest of these, which is bounding the tail. So when the world catches fire, what happens? And I think that there's a really good debate to make about, or good argument to make about how much you should be budgeting for risk in your SLOs, which has a lot of implications for what you can do and can't do with error budgeting, right? So if you budget for all of the risks that might happen, and you're really aiming that you will always satisfy your SLO, you need to start loading in all of these risks into the equation. Like, for example, at some point an asteroid could hit the Earth. That's very unlikely, right? But it is likely at some point someone is going to introduce bugs in your software. It is likely that there'll be infrastructure problems. It is likely that, you know, there'll be some sort of catastrophe in your data center or some underlying service that fails in a catastrophic way. And all of these things need to be aggregated into your idea of the service that you're going to provide. The amount of uncertainty in those is really substantial, and this leads to a big gap between the SLOs that are being promised and the SLOs that are delivered, right? And the problem there is then you have a lot of space for your error budget. And if you start actually budgeting for everything that can go wrong, you have a bunch of error budget that you should ostensibly be spending, right? So do you spend your asteroid error budget? Like, at some point, everything could be down for a really long time. Like, you know, that could happen, but that seems really irresponsible to spend on a regular basis, right? And so there's a lot of fuzziness in here. On the flip side, when you talk about really, really bad things, there's going to be a bad disaster, right? It just happens. What the consumer really wants is indemnification. They want to be able to say, look, this won't happen. Like, I want complete protection. Okay, there we go. Complete protection from this sort of catastrophic failure. And so that's also a little bit problematic. I'll go through each of these sections and talk about them some more. But as you think about this, what this is really saying is that people want lots and lots of different things about SLOs, right? And you may want some of these, you may not want others. There may be other things that you want to get out of SLOs that I didn't list here at all. But what that means is that there's not going to be one answer. There's not going to be one-size-fits-all solution or method or number, right? We can't give you, you know, a graph with an integer between 1 and 100 that says how good you're doing today. Like, it's just not going to work. This is going to be much more nuanced, and we just need to reconcile ourselves to that. So I'm going to go through each of the areas, and then towards the end of the talk, I'll talk about some big open problems that we have that we need to solve. Okay, so on an ongoing perspective, this is the part that you'll all be very familiar with, right? So you need to, in addition to setting your SLOs, review the delivered performance, right? So you have metrics, you look at them. You need to conduct periodic reviews of your performance and your SLOs to figure out, you know, how they fit and what you should be doing. You may discover, for example, that you're wildly over-delivering your SLOs, which should probably cause you to consider offering higher SLOs, or that you're under-delivering them and you should start to either prioritize fixing that problem or lowering your SLOs. It's also really important to talk to customers and find out what experience they're having, because they will perceive the system in a very different way than you will. You also need to analyze changes to the architecture of your service as it changes. So for example, you will be implementing metrics in your service. We had an example of one service that had an SLO on a method that had been initially implemented as a synchronous call, and at some point that call became asynchronous. So our SLO went from measuring a thing that our customers cared about to measuring the behavior of a queue. And it turns out queues are super reliable and they're low latency and completely useless to our customers, right? So these things happen. People are changing lots of aspects of the system, and they won't always track things end to end. And then the third part is you need to understand the performance, the delivered performance of your dependencies and the changing SLOs of your dependencies. So things get optimized, they get faster, sometimes they get slower, you know, for lots of different reasons. Infrastructure changes, you implement something with a new data structure and it gets faster in one way or more expensive in another. And so you just need to keep on top of this and react to all of this, right? So you need to figure out what to do about it and really try to get to the point that you're refining your process and driving towards driving towards goals that reflect what you're delivering, so that there's some real symmetry there. The other thing that I think is really important is that this is going to end up being a set of living documents, and it's really critical that you document why you made the decisions that you made. So when you go and decide to lower your SLO because it turns out that there is some problem and you can't get higher than 2 nines, it's really important to document the rationale, because at some point that may change, or it may become important to change. So you want to talk about limiting factors, and also if there's customer requirements that come in that, that are critical in some way, that should be documented in some place that is going to be referred to as you go through this process. So at the end of the day, I think this is really all about trying to line up what you're delivering with what you say you're delivering, and having a nice, clean process there. So on to the design process. So this is all about what's being promised and what a consumer can infer about the way the service will behave, right? And frequently, consumers will want to know a lot more than what the providers can guarantee, right? But at the end of the day, their service depends on how the dependent infrastructure actually works. So what goes wrong? So aggregation destroys detail, right? Anytime you take a pool of events and put them in a bucket and don't differentiate anymore, you lose detail. And sometimes that detail isn't important. For example, you might have a request ID. You don't need to keep a separate bucket per request ID. That would not really provide you good trending information. But the other extreme is also really problematic. So if you put everything in one bucket, you start to lose fidelity. So for example, you might want to see error rates by version of service, right? Or you might want to see you might want to be able to distinguish between customer traffic and prober traffic, where you're expecting errors or you don't care about errors so much. And so you need to just be very careful there. Also, from the perspective of communicating requirements to customers, they care a lot more about the median than the tail, right? They care about the tail from a worst case scenario perspective, but services run at the median, right? And so that really dominates the day-over-day performance that they get. And so it's important to keep that in mind. In my experience, errors are very rarely evenly distributed, right? So they aren't random bit errors. They are, there is some interaction between a feature that this customer is using and a policy that they set up, or something that is really very customer specific. And if you assume that your errors are going to be evenly distributed, you're going to end up with trouble there. Also, a lot of important operations happen at low QPS, which puts us solidly out of a statistical regime. And this is a huge problem, because these operations are often quite important. And all of our methods really don't work very well for them. And then the last category, and this is, so analytics workloads are really weird in that customers may be handing us SQL or executable code, right? And when we have a service where there's shared responsibility between us and the user, where we're providing infrastructure and we're trying to execute something that the user gave us, there's always potential for user error, right? So if there's a typo in the SQL or whatever, that shouldn't necessarily count against our SLO because we're properly executing the thing that they gave us. However, this is an extreme weak spot because user errors can be really, really hard to definitively classify. And I've actually seen a bunch of recent errors where we misclassify things as user errors. So this is an important thing to watch out for. Okay, so when you want to do a better job of supporting design, there's a couple of things you can do. So you need to figure out if you're in a uniform error situation or not. You might be. In my experience, this doesn't happen very often, but if you're going to assume that your errors are evenly distributed, you should really verify that up front. You need to set per customer SLOs. These are just critical because at the end of the day, your customers care about the experience they're having, not the experience that the aggregate of all customers that use the service are having, right? If, for example, you have a service that has suddenly an elevated error rate, but it's small and it's within the error budget, but it turns out that that's all one customer, this is a huge problem, and that customer is going to care an awful lot. So I think it's also really important to think about adding bracketed median SLOs in addition to tail SLOs, right? Bound the behavior that customers can expect to see on a regular basis, because that's the behavior that they're going to see the vast majority of the time. And we have another sort of joke at Google that if all of our services started acting at their published SLOs, yeah, that's the one, right? Uh-oh. What? Oh, great. Thank you, Google. That is what we need. OK. So, yeah. Boy, it's even better when there's the GVC units that are voice activated. Oh, wait. No, that's not the right link. Sorry. This display is really blurry. OK. OK, here. So, so we have this crack that if all of our services at Google started actually staying with their published SLO, everything would fall apart, right? Because there's so much padding in at every level that things would just get slower and slower. You know, for example, our you know, the cluster manager scheduling SLO for a new task is minutes, right? And if that just started happening all the time, all of our reactive systems would get very, very slow and not be able to fix issues. And you know, rollouts would grind to a halt and so forth. And so it's really important to start to guarantee behavior at median in addition to at the tail. So the other thing, for low QPS workloads, supplementation can help, but it only helps to improve the quality over the long term. It doesn't actually improve the delivered behavior to any given customer, right? At the end of the day, if there's a low QPS workload and you're sending in your query a day to do something that's valuable, the fact that there are other requests that work doesn't really matter, right? The value of supplementation here is to improve detection of problems and to improve the quality of the service over the long haul. It's not going to improve the experience of another user of the service today that's having issues. And you just need to be super careful around error code, or sorry, user error classification. So just a quick observation about all of these. Some of these have to do with how we're defining SLOs. Some of these have to do with other techniques that we can use to shore up the use cases that we want to count on SLOs for, right? And I think that this is an ongoing trend. Like, SLOs are a really useful construct to think about. They are not a silver bullet. And so what you need to do is you need to figure out what the problem that you're trying to solve is, and then what all of the tools that you can bring to bear on it are in order to get the problem solved. Oh yeah, and canary cells for validation of user workloads. All right, so another thing you can do for user workloads is give users the ability to validate those early so that at least it doesn't affect production traffic when there's a problem. User workloads are particularly bad when customers are giving you things that are very hard for you to qualify. OK, the last bit, and this is, I think, a long-running debate in SLOs. You know, the debate is, should I set my SLOs based on kind of eyeballing the numbers that I get, or should I set my SLOs in terms of doing some sort of analysis of, you know, what the service should deliver and what the dependencies should deliver? I think there are certain things that happen infrequently enough that all you can do is gather data about what's happened, right? And so it is useful to try to set time to resolution expectations with historical data. That's all you can do. Now the problem is, for historical data, past results don't, what's the financial services disclaimer? Past results don't indicate future gains. So, you know, this won't give you any sort of promise, but it will actually give you a sense of what's going on. OK, so for the second part here, what we really want to do is look at the mechanics of the response, right? So we want to make sure that problems are adequately recognized, prioritized, and solved. So what goes wrong? Really, this is all about no shared understanding of what's happening. So there's a service that's having an issue, and it has a dependency that thinks that everything is fine, is the typical way that this looks. So when there's a misestimation of impact, what ends up happening is the provider side of the equation thinks everything is cool because they're within their SLO. And at the end of the day, nobody's happy, right? Because everything happens under higher pressure, problems are mitigated later, things aren't prioritized properly, and all of this is pretty rough. And also, low QPS rears its ugly head here again, in that there often isn't enough data to aggregate to notice that there's a problem, right? And so that's another way that it can be difficult to figure out what's going on. Okay, so what should you do? I think the first thing is, this is the place where we need to recognize that our tools are not up to the job all the time. And if someone contacts you and says, hey, my service is down and I think it's your service's fault, you should be empathetic and try to figure out what's going on. I think this is pretty important. I think it's also pretty important to clearly communicate the effect of service behavior changes, right? So there will be times when something is expected to change, and there will be times when nothing is expected to change and something has. And this is a good thing to be able to communicate about. And the more that you communicate about the expectation of changes, the more you'll be able to get through this process quickly. Again, per customer SLOs. And I think it's worth spending extra effort on validating and measuring low QPS APIs, because low QPS APIs are just really a weak spot in all this. Okay, and now to the scariest part of all of this. So tail behavior. This is what we, at the end of the day, what we want to do is we want to make sure that things don't go really bad when they go bad. But things go bad, right? The answer to what goes wrong at the tail is everything, right? This is where all the bad stuff happens, and it happens just not very often, right? The best first example to use is probably not, has anybody had an asteroid hit their data center? It probably hasn't happened yet, but it will happen, right?
You're threatening.
What?
You're threatening us.
Well, but all of these things happen, right? Every time there's one of these situations where you're like, oh, well, this crazy thing could never happen. At some point, it happens, right? And the problem is that you can never budget for all of that stuff, right? This is the clause in insurance contracts about acts of God and lightning strikes and things like that, right? These things are just very unlikely and really problematic. And once you start talking about the tail, you're talking about small population statistics, right? As an aside, one of the things that I think is kind of cool about SRE is that we explore the tail. That's really, if you think about it, what SREs do. Devs write the code, they have a model of what's going to happen, they write some unit tests and some integration tests to kind of exercise things and make sure it's all working the way that they do. But when really weird stuff happens in production, that's what we do. And that's the tail, right? So what do? You explore it, you find bits and pieces, you project out. But SLOs don't work here, right? SLOs are predicated on a bunch of assumptions that just don't hold when you're at the tail. So for example, you have a 5.9 service. So a 5.9 service is allowed roughly 5 minutes of outage a year. What happens in hour 5 of an outage for this service? Your SLO is gone, everybody's having a real bad day. A lot of people are having a real bad day. But the fact that it's a 5.9 SLO no longer holds and no longer matters to first approximation. You're just in a bad spot, and you need to get out of that bad spot. Does it matter what the magnitude, the count of failed requests is? Not to first approximation, you just need to mitigate whatever the problem is and get the service righted. And all of these problems compound themselves, right? Because all of your dependencies have a tail too. They're all going to have bad days too. And so I think that this whole idea that we can manage tail behavior in SLOs is actually really dodgy. I'm not very comfortable with the idea that this works. And if you really try to get to hardcore indemnification at this level, I think it's completely impossible, right? There's too many things that can go wrong, and you just can't protect against behavior. Right? The closest that we can get to indemnification is SLAs, where there are actual consequences for failure, right? And those are financial consequences. But that doesn't actually say that those failures will never happen. They'll just say that those failures are really bad, and if that happens, here's what we'll do to sort of, try to mitigate it in a financial way. So the tail is super sketchy. My recommendation is don't try to handle this with SLOs. Right? So if you try to handle this part with SLOs, you're in for sadness. And you're in for sadness for a bunch of different reasons. So you're going to have bad days. Like, they're just going to happen, right? And there's nothing, setting a higher or a lower SLO is not going to change that, right? I think that this is sandbagging, right? So what you're doing is you're sandbagging your SLOs for a rainy day. You're saying at some point the asteroid will come, and when the asteroid comes, I want to have some coverage in my SLO, and so I'm going to pad. And I'm going to have a whole bunch of error budget that I will never ever spend that I'm saving for when the asteroid hits. Now the problem with this is that that blinds you the rest of the time. Right? There's some expected behavior, and there's a huge gap between expected behavior and delivered behavior, or sorry, promised behavior and delivered behavior. And so when the service changes, and it changes not in a catastrophic way, but your availability goes down. But it's okay because the asteroid was going to hit, and so I padded by an order of magnitude in my SLO in order to address that. You're just blind, right? You don't see those things nearly as early as you should, and then those problems are just much larger and harder to solve. Also consider, in this regime, error budgets are a terrible idea because you're budgeting for your worst case scenario, and the guidance around error budgets is that you should be spending them when you don't use them for operational incidents. So if you're budgeting for the asteroid, should you be spending that down every week? Like, I don't think that's safe. Like, I think that there's a lot of cases where error budgets are just not fundamentally safe unless your SLOs are really, really high fidelity and accurately tuned, which I would maintain that is probably not true for anyone in this room, right? Maybe Murali, because he's got a super mature service. But like, not, but no, seriously, like this is a big problem. And so I think it's worthwhile to be very, very careful around that. And if you're going to indemnify very conservatively, because you don't know what your bad day is going to look like, and it's certainly not going to look like your normal SLO. I think that the best that we can do here, again, it gets back to tracking historical data. Like, look at time to resolution for incidents, look at outage causes, track all of this data, manage it through your normal management cycle. And do the standard, SRE postmortem thing. Learn as much as you can when these things happen. Try to apply best practices cross-service, and really try to harden your services, because you really want to avoid these sorts of incidents. Like, these are just the worst of the worst. And then the last thing is, when you can soften dependencies, absolutely soften dependencies. Oh, sorry, second to last thing. And dirt. Like, lots of dirt testing, because the only way to really test what's going to happen when things are going wrong.
What's dirt?
Oh, sorry. So dirt is disaster testing, right? This is actually popping the breakers on a data center, or turning down a service while a bunch of things are depending on it, or exercising live failures, right? Seeing what actually happens in a failure mode for a service. Oh. Why is that? Oh, that's weird. Okay. That has power save too. Okay. Okay, so I have small children. I need to make occasional puns. So we have some sloping problems. So these are a couple of things that are just big open issues. So I think that we have a bunch of SLO model failures that we need to address. So we assume a bunch of things in the model of services, like I was talking about earlier. There are statistical methods to address these problems, right? We don't need to assume that all requests are independent. We don't need to assume that there's no data dependency or locality. We don't need to assume that all of our requests are worth the same thing. There are methods for these. We just need to learn how to use them. I think that we need good measures for SLO fidelity. How good of a job are SLOs doing at solving the problems that we want to solve with them? I think this gets back to trying to tie to the use cases, but fundamentally, we need to have measures that tell us if this is working well or not. The fact that you have SLOs is a first step, but I think that maturity really needs to look like an ongoing feedback cycle where we can tell how well our SLOs match what we're trying to deliver versus what we are delivering versus how well our customers' expectations are being matched with a full feedback loop there. We have kind of an intuitive sense for parts of this, and it's not good today. And then the last part is we need an algebra to combine SLO expectations so that we can figure out what we should expect from services that consume lots of downstream services. State of the art here is pad by an order of magnitude. If you're going to consume some 4.9 services, the best that you can hope to achieve for your service is a 3.9 service. It turns out we have more numbers than just 9 and orders of magnitude, and like math is richer than that, and we should probably try to figure it out. There's a bunch of issues that we need to consider here, like shared fate of dependencies and fail open and closed behavior and things like that. But fundamentally, we need methods to be able to take a set of expectations around how services are going to behave and build up in an analytical fashion in a predictive way. Okay, so SLOs are a powerful tool. I think that we all sort of intuitively know that if used properly. However, I think that there's a lot of room for misuse. But the most important thing is they aren't the goal, the use cases are. And we need to really, I think, stay very focused on the use cases. And often you need something to supplement SLOs in order to get to where you need to get. You can't promise your way out of every situation. So Evelyn promised to heckle, and I will reverse heckle. Right? Like Evelyn's a funny guy, right? But saying that he's 4.9's funny doesn't make him any more or less funny than he otherwise would be, right? So setting the promise doesn't help by itself. Well, I mean, this is the debate that you have, right? But you need to collect data and find out over time. So the thing is that SLOs by themselves are not enough. And so you also need to manage to them. You need techniques around them to reinforce the goals that you're trying to achieve. And then the last part is, we've talked about a ton of use cases. You probably don't need all of these. Focus on the ones you need and make those work well. Also, there's a bunch of technical rough edges, and if you're interested, come talk to me. And this is where we want to get, where we have detailed maps that are useful, right? And I think that we can get there over time, but it's going to take some work. And that's it. Thank you.
Thank you very much. We've got about 5 minutes for questions. So first, given that John was heckling before without a microphone, I've now handed him a microphone so he can heckle properly. So we'll start with you, John.
I'll also be available for heckling while people are trying to ask questions. So one thing you did not touch on is I used to use SLOs as an aspirational guide to both my SREs on the team, but also people using my service. So I might say, yes, we can't do 99th percentile right now, but we're going to give you an SLO of that because we think we're going to get there within the next year. Please design your services assuming that's available. And forgive us in the meantime.
Sure. Yeah, I think that's a reasonable way to go.
Okay.
Right? I mean, the thing is that hitting these things, as long as that's well documented, I think that actually one of the underappreciated aspects of SLOs is that they can tell you where the service is going or what to expect. Internally, we have a bunch of SLOs for very mature services that encode a lot of the architectural aspects of the service in a way that's useful for consumers to understand, right? And that kind of documentation where you're saying, look, we can't get to 99th percentile today, but we're working on that. That's a great example of that kind of thing.
Narayan, how are you? So, lots to respond to in that talk. I think actually this is something that deserves continued attention, and we should see further iterations of this talk and exploring of this problem space. But I want to focus on a very, very narrow piece there, which is your conversation around error budgets. So I think the first thing to say is that when you point out that an error budget is actually primarily a software delivery control mechanism, which is what I hear you saying there. We don't need to do that with SLOs. We could do it in another way, and we could narrow the scope of the tool of SLOs, or what we're using SLOs for on a tooling basis. This is particularly forcefully clear to me when I think about the trade-off between error budgets applied on the scope of days or weeks versus an end of quarter blowout for 5 hours or whatever. I agree with you that it absolutely makes very little sense from the customer point of view if their usage of the product is continual to say, we will screw you for 5 hours at the end of the quarter, but the rest of the time it'll be totally fine. A lot of the intellectual underpinning for error budgets is based on an implicit assumption about customer usage. which we could probably tease apart and explore a bit more in order to extend that idea.
So I think that it's worth distinguishing between the tail and normal operations, right? One of the things, as I was, frequently when you go through the process of trying to write something or produce slides, you end up in the situation where you understand it better. I think one of the things that I didn't fully appreciate until I'd finished the slides was that we really need to distinguish between normal state and catastrophic state in a much more robust way than we do now, right? And I think that error budgets as a software control mechanism actually work pretty well. It's when error budgets interact with sort of catastrophic risk management that all hell breaks loose. And that's what we need to avoid most of all. And so in general, I'm actually on board with this sort of freeze-thaw, go faster or slower sort of mechanism with error budget or being able to experiment or things like that in general, as long as it's bounded in a very narrow sense.
Yeah, I see somewhere in the Platonic copy of your deck some diagram which has the validity of application of each of the use cases that you're talking about in red, green cells. Anyway.
Thank you. If you've got time for one more comment, and by the way, I should say that Niall is the author of, one of the 4 authors of the SRE book, so he gets to do more of a comment, really. The rest of you, not so much. Anyone else for the... I see a hand up over here. Yeah.
So very similar to what you were just saying, our system this year, we had a long tail event, which we realized through calculating our error budget, it would be about 3.5 years before we'd restored our error budget. And it was also such a rare event that we realized there was actually nothing we could change in our practices that would help us recover from such an event faster in the future. And we had this existential problem of what do we do? Do we just hit reset on our error budgets and start from fresh? Or what is the window? And we realized what we really need to calculate is how long will it take for our customers to restore trust in us after this event? And the error budget didn't seem to help us with that decision at all. So I was wondering if you have any thoughts of that sort of trust building is really what it comes down to when you have those long tail events, and is there some other mechanism we need to capture that better?
So one of the things about freezes that I think is very interesting, so you're absolutely right, trust is a big aspect of this. One of the things about about the freeze-thaw issue after an outage is that you're often in a situation, you were in a situation where there was unfortunately nothing you could do. There are also situations where there was a bug, you fixed the bug, you have a mitigation, you can detect the situation, and if it happened again, it would be good. But you've still just had a massive outage, right? And so there's frequently this sort of urge not to freeze because analytically there's nothing left to do, right? But one of the things that's missing, I think, from that line of reasoning is that your customers need stability. And one of the huge error vectors for systems is people. Whether they're operating it, whether they're writing new features, whether you're trying to test new features out in production, whatever you're doing, there is going to be more risk if you're pushing code to your service. Empirically, that's what we've seen. And so that'll always, I think, be true. But I think that what you're talking about with trust fundamentally is not compatible with the idea of a rolling window, right? I'm going to date myself a little bit here, but there was a long time that I had lost data to every file system in the Linux kernel, right? And you don't forget that. It's not in a 30-day rolling window or a 1-year rolling window. JFS is forever dead to me because it lost me some data back in 2002. And that's how trust works. Trust doesn't work because the rolling window expired. And that's not how it's going to work, right? And I don't think that we can count on these sorts of mechanisms to restore user trust. Fundamentally, I just don't think that works. I think that what we need to do, again, is supplement it with other stuff, right? So talk to our customers and figure out what would get them more comfort in the system, and how would they, what's the best way to help them to redevelop trust in the system? Because that's the exercise. At the end of the day, that's the problem that you have to solve, much more than do we freeze or not. And I think that's an example of flipping the question around from looking at the mechanisms like what do we do with our SLOs or our error budgets to how do we achieve the goal that we want, which is restoring user trust.
Thank you so much. Thank you.